All right, 8th grade, welcome to Redzone number 2, which is all about functions. Hopefully you remember what functions are. Functions is a topic that will come up in 9th grade algebra. Not so much in 10th grade geometry, but you will see it again in 11th grade algebra 2 trig. So it's a topic that you need to know. You need to know how to write about it. You need to know the definition. You need to know how to tell if something is a function. If you don't remember what a function is, let's maybe use it in a sentence. Sometimes that helps. Mine are like parachutes, the only function went up. Nope, wrong kind of function. Sorry. Actual footage of me waking up and trying to function. Nope, wrong type of function. Again, this looks right. This table represents a function since each x value matches up with one and only one y value. So if you remember, a function is a relationship where each x value only has one y value. If an x value has more than one y value, then it is not a function. If you notice in this table, some of the x values have the same y value. That's okay. As long as each one of these x values, as long as you can look at each one and tell me what the one y value is that goes with it, then it's a function. So if I say, look at the x value of 0, what y value goes with it, then you would tell me 6. That's how I know that that only has one y value. But if I added another coordinate here, 0 and 8, if I put that on the table, I'll slip it in right there. And now I say, look at the x value of 0, what y value goes with it, you would have to go, oh, there's two y values, 6 and 8. That's not a function. So there could only be one y value that goes with each x value. So here are a couple of examples. We'll do these together, and then after this you can just pause the video, do them yourself, and then unpause it to self-assess and see if you're getting them right. So number 1, it says determine whether each set of ordered pairs represents a function. Remember that ordered pairs is just another word for coordinate or point. So we look at number 1, we have 0, 0, 2, 1, 4, 2, and 6, 3. To see if it's a function, we have to see if each x value only has one y value. So first I look at the x value of 0, which I'm going to get a pen out right here. I look at that x value. What y value goes with it? 0. Anything else? No. So that's good. This one has an x value of 2, and it has a y value of 1. Yep, we're good. There's no other y value that goes with the x value of 2. 4 goes with the y value of 2, and 6 goes with the y value of 3. So yes, this one is a function. So I get to number 2, and I go through it the same way. And I don't have to go through it that slowly each time once you get the hang of it. -8 only goes with 5. -6 only goes with 4. -2, oh, that also goes with 4, but that's okay. It's okay if the y values repeat. So that's a good note to remember. It's okay if the y values repeat. So I'll put that in bold and put it in a nice bright color so we can see it. Make it nice and big. And then the last x value is 0, and it goes with the y value of 2. So that's fine. So yes, again, this is a function. And it says right here, remember, a function cannot have two different outputs for the same input. Input is x, output is y. It can, however, have two different inputs for the same output. That's what this note means. It's okay if the y values repeat. So we look at number 3, and I see, okay, x value of -3 goes with -4, but wait a minute, it also goes with -1, 2, and 5. So -3, let me write it, type it so it's a little neater. The x value, -3, has 4 different y values that go with it. So this is not a function. And it's not a function because of the reason I just wrote down. So that's something that you could write down if you want to say something is not a function. You could be specific and say that this x value has 4 different y values. It has more than one y value. It should only have one. So again, make sure that each x value only matches up with one y value. That would be a function. All right, so here's two more. They already answered it for you. You just have to write a good reason. So pause the video here, and when you unpause it, in about 5 seconds, I'm going to go over it. Okay, the relation 0, 0, 1, 1, 2, 4, and 3, 9 represent a function because, well, each x value, and I'm typing in the wrong spot, but that's okay. Each x value only has one y value. That's the definition of a function, and we could just write it there. Number 5, the relation does not represent a function because the x value, -2, has two different y values. And this one I remember students making mistakes on because the x value of -2, which is here and here, has a y value of 2 and -2. Those are two very different numbers. +2 and -2 are different. So that x value has two different y values. This one's fine and that one's fine. The problem is here and here. All right, same thing when you get here. Pause it, do the question, and then unpause it, and I'm going to go over it. In each table, x represents the input and y represents the output. Which table does not represent a function? So if I look through the table, choice A, each x value seems to only be going with one y value, so that's good. B, there's 4 different x values, and they each only go with one y value, so that's fine. C, 4 different x values. They're all going to the same y value, but remember, that's okay. Check. And D, here's a problem. The x value of 3 goes with 0, it goes with 1, it goes with 2, and it goes with 3. So again, 4 different y values. So that's our answer. That's not a function. All right, this bottom question is obviously a little different. Let me get rid of all this ink. I'm just going to move it up. There we go. So it says, which one describes a linear function? A linear function is one type of function. Next year, you're going to learn two other types of function. Well, more than 2 other. You're going to learn more. So a linear function is a function that represents a straight line, and more importantly, has a constant rate of change. So you could tell that something is a straight line when it has a constant rate of, and remember that rate of change is just another word for slope. The other thing to keep in mind is that all linear functions can be written in the form y equals mx plus b. They're not all going to be given in that form, but they can be. I'm going to start a new page right now just to show you some examples. So things that are no good. So these are all going to be equations that are not linear. So if the variable has an exponent other than 1. So for example, y equals 5x squared plus 6. That's nonlinear. Or y squared equals 5x, nonlinear. Or, if you remember, a formula you learned last year, area equals pi times the radius squared. All of those are nonlinear. Another example of an equation that is nonlinear is when the variable is in the denominator of a fraction. So here's an example. Y equals 6 over x. Because the x is in the denominator of a fraction, that would be nonlinear. Now here are some examples of equations that are linear that you can expect to see. So you might see things like very straightforward, y equals 2x plus 3, y equals 1/2 x plus 6. Those are in slope-intercept form, y equals mx plus b. you might just see something like y equals 6. That is linear. That's still in slope-intercept form. You might see y equals x over 4. This one kind of looks like that other one we talked about, but since that's in the numerator, we're okay. You might see a formula like distance equals rate times time. That is linear. Nothing here breaking the rules. Which brings us back to this question. Pause it, and then I'll go over the answer in about 5 seconds. So when you unpause it, you'll see the answer. All right, so which one's linear? Well, the first one, the variable has an exponent, so that's no good. The second one looks good. Y equals 1 over 6 times x. We'll continue just to check. In C, that's one I forgot to talk about. In this one, the variable is an exponent, so that's no good. And in the last one, we just talked about that. The variable has an exponent, that's no good, so B is the answer. Here's the last page we're going to do in this video. This time, just pause it. 5 seconds, the answers are going to be there, and then I'll briefly talk about each one. All right, so the first one is an old state exam question that has tripped up pretty much every 8th grader since the question has come about. It says, which one could represent a linear function? Most students get it down to A or C. They realize that B and D are not functions because they have repeating x values. So then they don't know what to pick. A and C are both functions, so how can only one be the answer? The key is that it says it has to be linear. Remember that linear means that it follows a constant rate of change, a constant slope. So if you look at choice C, the y values are going up 5, up 5, up 5, and the x values are going up 2, up 2, up 2. So it has a slope, a constant slope, 5 over 2. In A, the y values are going down 4, then down 1, then down 1. So negative 4, negative 1, negative 1, not linear. So it's choice C. The second one was pretty straightforward, and the third one also pretty straightforward. If you have questions, reach out to your teachers, look up things on YouTube and Google, refresh your memory what a function is. You might think that the year's almost over, but you need to know this for high school. And so if you want to do well in high school, master this stuff now. Good luck.